Welcome to Physics for 11th classes. This is your Satish sir. In this section, we can see the gravitational force of attraction between a rod of mass m and a length L with the point mass. So far we have seen the force between the 2 point masses, which we can use F is equal to G m1 m2 by r square, where r is the separation between the 2 point masses. Here the case is slightly different. There you can see I am taking the two bodies. The one body is the extended object of mass m and length L, which is called as a rod. Uniform distribution of mass is given here. The second object is the point mass. And the separation between these two, from the one end is taken as D and the other end comes as L plus T. And to find the force of attraction between these two, initially we need to take a small element from the rod. Suppose if I take the small element here, and this small element has a mass dm of length, let it be taken dx, and this element is at a distance from this point mass, let it be taken x, where x is the separation between the given point mass and the element we are chosen. There we can write the force of attraction between this point mass and this element, how much it is, as dF is equal to G into m1 m2 by r square, where m1 is the point mass and m2 is the element we are choosing. How much is mass? dm, divided by the separation between these two is taken as x. It comes as x square. And we need to express dm in terms of its the given parameters, its mass, length, like this. So what we can write? So dm is equal to mass per unit length into the given length, which means I can write in this way: the L length has the mass m, a rod of length L which possesses the entire mass capital M. For unit length, you will get the mass how much, m by L, and for the given length we are choosing how much it is, dx, you will get the mass m by L into dx. So this element having the mass dm, which is equal to how much, m by L into dx. So replace dm with this parameter, then you will get df is equal to g m into dm is how much, m by L into dx divided by x square. And we need to integrate this entire expression between the two limits. The one is, and the end of this rod is at a distance d from the point mass. The other is at a distance d plus L. So we need to integrate this one between the limits from this point to this point. This point is at a distance d. So from small d to d plus L, we need to integrate this entire expression. Then you will get the force of attraction between the rod and the point mass. So therefore F is equal to, so what are the constant terms you can take out of the integration? So G, capital M, small m, divided by L, and integral of, the remaining thing is 1 by x square into dx between the limits d to d plus L. And if you take integral of 1 by x square dx, how much it is? We know integral of x power n dx is x power n plus 1 by n plus 1. If you apply this one, you will get which is equal to, there you can take this entire term as a constant. For simplicity, let it be taken as k. At last I can replace k with this term k. So integration of this one, you will get x to the power of minus 2, which means integral of x power minus 2 is x power n plus 1. So minus 2 plus 1 divided by minus 2 plus 1 with the limits d to d plus n. And that is equal to k into how much you will get here? Minus 2 plus 1 minus 1. You will get negative sign outside, which is equal to minus. And the limits you can take 1 by x. So with the limits d to d plus l, suppose if I take off minus here, you can interchange both the limits. So this you can take it as d plus l and upper comes as d. By taking off this negative sign, I am interchanging the limits. And finally you will get so k times of upper limit 1 by d minus substitution of lower limit 1 by d plus l. If you take the LCM of these two, and finally you will get the last expression f is equal to k, constant k into d into d plus l comes as the LCM, and here cross multiply d plus l minus d get cancelled, and that is equal to k times of l divided by d into d plus n. What is k? S. G mm by L is k. So replace this one. So G capital M small m divided by L into L upon d into d plus n. L get cancelled, and the final result is G mm divided by d into d plus n. And you just remember this result when the one object is given as a rod of mass m and length l, and second one is the point mass. And from point mass to the one end of the rod, the distance is d is given, and there you will get the final result G mm, the mass of the two bodies, the extended body with the point mass divided by the product of the distances. The one is the distance from point mass to the first end of the rod, and the second is from the point mass to the second end of the rod, which is nothing but d plus l. So the product of these two distances, you will get the final result. So in the examinations, we directly remember this result to apply this kind of question.